decks, pavements, and parking structures. So friends, high performance concrete is not a concrete which used generally. It is specified and it is for the requirement of the projects. So strength of the class A HPC is generally reported to be greater than 60 MPa. So high volume fly ash concrete system has emerged as a powerful tool for future that would be far more durable and resource efficient, because addition of the fly ash in the concrete, it enhances the properties of the concrete. So these are the application areas. I have already said that the East Bridge of Great Belt link in Denmark, wherein the high performance concrete has been used. So there is another category which is ultra high performance concrete. Herein the concrete strength goes in excess of 150 MPa. It's not there in code, because in IS code it is M80 which is last. But all over the world, the R&D people in civil engineering and in concrete technology, they have gone beyond M50 and 150 MPa up to possibly exceeding 250 MPa concrete strength. So ultra high performance concrete is characterized by its construction materials, fine grain, sand, silica fume, small steel fibers, special blends of high strength Portland cement, volume modifying agents, and many things are used to produce this kind of concrete. Any student from Abhilashi University is into the field of PhD, they can get in touch with us and we can interact on these platforms. So ultra high performance concrete, you can see the finish of the concrete. I don't think we have seen this kind of concrete structure during our normal day life. So these are the specially designed concretes, and you can get a butter-like finish in concrete also. That is also possible, because all over the world they say there are 4 stages in construction. In India, 85 to 90% or even 95% construction is going on as stage 1, wherein we are doing brick mortar, site mix, and ready mix concrete construction. Construction practices are at a level 1. And level 2 is a panel type of construction, wherein we design our members panels in a factory and then we assemble them on site. That is the level 2. And level 3, which has also emerged all over the world, is a box type of construction. We do full room box ready in a factory, and then we take that box and put it on the floor like it is done for the soil, this oil filter, oil refinery rig offshore sites as well as ships. This is how they are starting the construction and doing that. So that is the level 3. Level 4 goes to the artificial intelligence type of construction, 3D printing and concrete cloth, using concrete cloth for the construction. That is the so in India we are 90 to 95% at level 1, and currently we have started using panel constructions as well. We are trying to go for panels in roads also. So another category is fiber road reinforced concrete, in which you add short discrete fibers and they are uniformly distributed. Fibers could be of steel, FRP material, glass fiber, synthetic, natural fibers are also used, because people, I have already told you that all over the world people are exploring concrete because the usage is enormous. It is second most consumed building material, after water in the world on per capita basis. I have already told. So people in the different countries, in the different R&D labs, they are exploring the possibilities of adding different kind of natural fibers in the concrete, each of which lend varying properties to the concrete. So fibers are usually used in concrete to control cracking, because there is a thermal cracking, there are other shrinkage cracking, plastic shrinkage cracking, drying shrinkage cracking. They also reduce permeability of the concrete and reduce bleeding of the water. The amount of the concrete mix expressed as the percentage, and that depends upon the design, 0.1 to 3%. And FRC subcategory named igneous cementitious composites claims 500 times more resistance to cracking and 40% lighter than traditional concrete. So to enhance the property of the concrete, the researchers, the civil engineers, the structural engineers, concrete technologists, they are exploring different varieties of addition of the things. Just see the view of the fractured sample of the fiber reinforced concrete. Fiber intrusions make it strong and durable and preferred at specific site with advantages. So self-curing concrete, this was, when the construction industry in Japan experienced a decline in the availability of skilled labor during 1980s, and there was a need because there was an earthquake. Necessity is the mother of invention. There was an earthquake in Japan, and they had to build, the nation again, the countries again, the city again, the houses again, the infrastructure again, and they were wanting, to be done it in a faster way, and there was, less of a skilled labor. And this self-compacting concrete, wherein you need not to vibrate only, this concrete was produced, and thereafter it is being used at all over the project, and mostly this is required projects where the reinforcement is very dense. It is almost impossible to vibrate concrete externally. These are the two areas main wherein we get a need to design self-compacting concrete. Basically, it is a concrete which automatically flows into the reinforcement, and according to the format, it gets its own shape and meeting the strength as well as the design and durability criteria at the site. So self-compacting materials are, proportions of, SCC differ from those of ordinary concrete in that former has more powder content and less of a coarse aggregate. And as we go up, we normally use 20 mm aggregates, coarse aggregate, as well as 10 mm aggregates. But as we go up in the strength, we normally go for the 10 mm or lesser coarser aggregates. So more self-compacting concrete incorporates high-range water reducers, the admixtures which are able to reduce the water cement ratio to the extent of 35, 30, and even 40%. Super plasticizer in larger amounts, and frequently a viscosity modifying VMA are also used. Self-compacting concrete has been used in bridge building, tunnel construction since early 1990s also. In the last 5 years, a number of SCC bridges has been high strength concrete, according to IS 456-2000, designate concrete having 20 days strength of M60 to M80, corresponding to grades. High strength concrete is designed, but to produce high grade of concrete, especially high performance, therein we require 90% of the construction that is happening in India is okay with the 43 grade of cement as well as the PPC cement. High strength concrete, it has therefore been widely used in the construction of high strength buildings and bridges in many countries' buildings. Is super high strength concrete called reactive powder concrete, wherein the powder content is more, is produced by eliminating the use of aggregates. Particle size, the water cement ratio is kept around 0.15. The desired verticality is obtained by using high amounts of super plasticizers. The rapid concrete, does not require reinforcement bars. It is suitable for the use of building very thin structures meeting different architectural needs. Atomic Power Station, Rawat Bhata and Tarapur, which are very huge concrete structures. Another category of concrete is lightweight concrete. Lightweight concrete material is produced by using coarse aggregate of lighter size. Lightweight aggregate may consist of processed shale clay process where the material expands and it results in less density. So weight per unit volume is reduced up to 50% or even 60% also. It's possible nowadays. Even concrete is made which can float over water. That is also possible. I have seen the sample, and we have one of the sample at our RMC plant also. That is also possible. So lightweight cellular building. This is one of the building which is of lightweight cellular concrete. ESDS is a tier 3 fully managed data center service provider in India. The entire building structure data center is on a single basalt rock. Floor walls are specially built using cellular lightweight concrete. So permeable concrete. Another variety of concrete is the concrete wherein you want to design a bathroom, wherein you want to take bath with the rainwater. That is also possible. You put on a slab, whatever rain is coming, that will percolate through the slab, and you can enjoy the rain as well. So permeable concrete is concrete which will absorb water. This type of concrete should be used. Definitely, it should be used for your pakka angans, courtyards, and the areas wherein light vehicles are going to increase. My dear friends, I would like to highlight here that there are countries, there are cities in the world wherein if you will do your courtyard as a pakka concrete, so you have to pay penalty to the municipal corporation, because every time you are doing pakka house or pakka courtyard, therein you are increasing the runoff of the water which your municipal corporation of that city has to maintain. Every time they have to size of the nala. So that is they are charging, pervious concrete, or you this concrete is also known as zero cement concrete, because you use cement and coarse aggregate only, and there are lot many voids and water percolates through it. So pervious concrete consists of cement, coarse aggregate, and water, and very little or no fine aggregates. The addition of small amount of strength. The mixture has a water to cement ratio of 0.28 to zero point 0.4 with a wide content of 15 to 25% from where the water can pass. So these are the permeable concrete solutions. I have already explained that we can use these for the parkways, courtyards, wherein the traffic is not much more heavy traffic is not going to come. Therein we can use this kind of concrete. Another variety is translucent concrete. It is that light is transmitting property due to embedded light,
Sorry to
optical
interrupt, sir.
elements, usually optical fibers,
Hello.
right?
Sorry
Yes,
to
sir.
interrupt, sir. Sir,
Yes, please.
your slides are not working properly. Your slides are not functioning. All the slides. So please represent it. Represent your screen.
Okay. Let me do once again.
Okay, sir. Thank you.
Let me do once again.
Okay, sir.
Okay, it's okay. Is it okay now?
Show me.
Is it okay?
No, sir. We are not able to see your
Can
screen now.
somebody respond, please?
So we are not able to see your screen.
You are not able to. Okay. Please keep on responding till the time it is okay.
Okay, sir.
Right?
Yes, sir.
Let me do it once again.
Sure, sir.
Now,
No, sir. It's not working.
is it okay now? See, signal is okay from my side. You can ask somebody else also. Are you able to see the screen?
No, sir.
No, proceed.
Sir, you can proceed. Yes, sir. Yes, sir. Now it's working.
Yes, sir, working.
Yes, sir.
Is it okay now?
Yes, sir.
Yes, sir.
Okay.
Thank you very much. So we have already discussed permeable concrete. Thank you very much. Permeable concrete. So another variety which I was discussing is translucent concrete, which emits light. This kind of sometimes you require this kind of concrete wherein you want these are all aesthetic properties. So trans-emitting concrete is a concrete based upon building material that emits light. Materials are used, and light is conducted through the stone from one end to other end. Several ways of producing translucent concrete exist. All are based on a fine grain of concrete. calcium 95%, and only 5% light conducting elements that are added during casting process. After setting, the concrete is cut to plates or stones with standard machinery and cutting stone materials. So translucent concrete is used in fine architecture as a facade material and for cladding of interior walls. Light transmitting concrete has also been applied to various design products. It was developed in 2001 by Hungarian architect. Mostly you must have seen a building which keeps on revolving. That was, there is only one architect whose name is Dr. David Fisher. He is the person who is designing the revolving structures in the world. You can search it on the Google. So this is also an architect who has designed this translucent concrete. So most of the innovation in the field of construction are coming from the customers or from the architectural side. So this we can see. This is the translucent concrete. You can see the picture. So vacuum concrete is another form of concrete made by using steam to produce vacuum inside a concrete mix. Truck to release the air bubble inside the concrete is being researched. The idea is that the steam displaces the air normally over the concrete. When the steam condenses into water, it will create a low pressure over the concrete that will pull air from the concrete. So this will make concrete stronger due to there being less air in the concrete. A drawback is that it is almost impossible to carry it on because you have to maintain the airtight container and airtight trucks. But research has been done in this direction also. This is a high flex solutions building done in Bangalore, wherein concrete has been used and very good. Shotcrete is another form of concrete which is normally used during tunneling process. There are two methods: dry shotcrete and wet shotcrete methods. It is a term wherein we produce concrete and we pump it and we put it onto the retaining walls. It is normally used for repair surfaces or for where the rocks are falling. So it is usually used to repair surfaces where concrete has deteriorated, repair is being done, or the soil surface it is falling, tunneling mostly. Used to build up a thin layer of concrete to protect steel from the corrosion. That there also it is used. The mortar is ejected from the nozzle under pressure of 175 to 345 kPa, and it is often used where forming is costly. You can almost not do the form work, or material handling of and installation is very difficult. So shotcrete is frequently used against vertical soil, rock surfaces, concrete repairs, or replacement on bridges, dams, pools, and other lot many areas. Shotcrete is also used for application where seepage is an issue to the limit amount of water entering to the construction site. Just to temporarily block the water or other way around. You can see the pictures. So there are two methods I have already told you. One is dry mix and another is wet mix. So dry mixture of the cement aggregate is filled into the machine and conveyed with compressed air to the pressure through the hoses, and water is just added at the nozzle point. On the other hand, it is pre-added and then it is sprayed. Lime concrete is a lime surki. It is very old concrete. This is the concrete from where the concrete has evolved, wherein instead of cement we were using lime as a binding property material or binding material. This is a beautiful structure, Statesman House, New Delhi, wherein concrete has been used. Cellular concrete is defined as a lightweight Portland cement concrete containing high percentage of gases, distinguishable from air voids in terms of cell sizes and long normal distribution, created mechanically by means of addition of foaming agent. We just add the foaming agent to make the volume more. So density can range from 320 to 1900 kg per meter cube. Characteristics depends upon the materials that we are adding and making the concrete. And the low density is possible because polymer concrete is another form of concrete wherein we add, these are whenever we add any material. So friends, let me give you an example. Today, if we are going to a restaurant.
Hello.
Yes.
Sorry to interrupt you, sir.
Right.
Your screen is not representing. We are unable to see the presentation. Only your face is covering.
Okay. Okay.
There is an option during the present now option. There is a present entire screen. Just make
I'm
sure.
doing that. I'm doing that. Yes, present entire screen. I don't know why it is disconnected.
Yes, sir.
Again, I'm doing that. Okay. I
Okay.
think you should be able to see now. Yeah. Is it okay now?
Sir, it should take some time. Let me check. It
Yes,
is presenting,
it
and
takes 60
right now
seconds.
it's a polymer concrete. Slide is polymer concrete. Is it so, sir?
Polymer concrete, yes, yes,
Yes, sir.
yes. Thank you very much.
Now.
Thank you.
Okay.
You please,
Okay, sir.
whenever you are not able to see,
Okay, sir.
just interrupt and I'll put it on hold. I'll take another 10 minutes, please. Yeah. Polymer concrete is another concrete wherein we add polymer. It can be implemented, it can be injected, it can be done during making the concrete, and we can polymerize the concrete. But basically, it is another gradient. The example which I was trying to quote in, my dear friends, the concrete is not the universal concrete that we have to use. The point which is coming out from all the varieties of the concrete is that we can get the concrete of our choice as per the design, and we can design concrete to the application. So these are the application of the polymer concrete. So this is the shape and the size and the beauty of the polymer concrete that you are able to see. Papercrete is another form, is an alternate construction material, made a paper like fibrous material mixed Portland cement and clay or soil. Papercrete dates back to 1928 when it was first patented. 1928. Since the late 80s, papercrete has had renewed interest in the alternative or environmental friendly material due to amount recycled paper used to make it. The fiber in papercrete makes it fairly flexible, which tends to crack less than stochomixes. It is commonly used in earth bags and rounded or dome structure. Once dry, it has fibrous texture and gray in color. Asphalt concrete, another form of concrete wherein we use, composite material used in construction projects such as road surfaces, airports, parks, lots, etc. It used asphalt as a binding material. Recycled aggregate concrete is another industry which is about to come, which has come in many big cities. So aggregates, we are doing is there is a mining ban on mining. We are not getting the fine aggregate and the coarse aggregate. So this is an industry which is about to come, wherein the old material, wherein we have done the demolition, deconstruction. From that material, we can do, get the recycled concrete aggregate. We can use them alternatively for making concrete. This is another eye-opening type of concrete, self-cleaning concrete. I think you must have heard about the self-cleansing glass. The glass on your, 150-story structure, wherein it will clean automatically. So self-cleaning concrete has also been made possible. Self-cleaning concrete, when used or in a concrete structure, photocatalyst decomposes organic materials that folds the surface. So the organic compounds are affected by particulates, whatever material is there, sticking on the surface, it will get. This is a building. Dives and Mycopodia church in raw material structured using self-cleansing concrete. So how it works? Whenever there is an rays from the sun, sunlight alter the light pollutants observed on the surface, and titanium dioxide coating that reacts with it, and final products are carbon dioxide and water that dissolves, and the surface is clean and green. So another example of concrete is Yamuna Expressway north to Agra, wherein big quantity of concrete used, 1.7 million cubic meter of concrete was used. And these are the concrete structure, beautiful structure, Viraste Khalsa Shri Anandpur Sahib. As a civil engineer, whenever you are visiting the structure, you must see these structures and see the beauty of the concrete that is possible with the concrete. This is the message I want to give. This is another Jadukata bridge and Lotus Temple at Delhi. And another variety of concrete is exposed aggregate concrete. Whenever we do mix concrete with the cement and mortar, it is a concrete, and only we get concrete of grayish color. But if you want their aggregates, which you have used coarse aggregate to expose and bring it to the natural form, So you can do that, and this is also possible. So friends, these are the varieties that I have explained, but in our RMC plant, why we go for ready mix concrete plant? Basically, we design Ultratech concrete is a performance because we are producing concrete, we are serving construction industry by supplying the concrete. So it is superior to conventional concrete. I have already explained. It has multiple applications. Expert quality systems for managing raw materials, efficient raw mixes, design, Q test, results, everything is done. And IS code is there, which we are following to produce the concrete, which is governing the production of the concrete. So we are giving the value-added concrete in the site. The latest development in concrete technology have made it possible to use it for performance and aesthetic appearance. Ultratech Concrete is committed to providing customized, high-quality RMC, which has versatile properties such as easy moldability, high compressive strength, and long-lasting durability for ensuring speedy construction. So we have got more than 108 plants because dedicated plants are also being put on the sites for the construction, like metros and other. We are present in 36 cities. We have 850 tonnage mixtures, pumps, and this is the concrete that we annually supply. So this is how we have evolved in ready mix concrete. This is the map, and we are present on these. And these are the application area. We give light concrete to the slab, wherein we want to decrease the weight dead load of the structure. We have a zip concrete, wherein you can get a concrete in a bucket, just like paint buckets. You can get a concrete in a bucket, and you can use it, and you can give the buckets back to us, because this concrete is required when in the market, the bazaar is very congested, wherein it is not.
Thank you so much, sir, for your wonderful presentation. Now we will turn the time over to our next speaker, Engineer Devinder Chawla, CMG Samriddhi Engineers Private Limited. He is BE Civil from REC Kurukshetra. In the year 1985, he completed his MTech CTM from Thapar University in 2000. He has the total experience of 35 years, and he is also an adjunct faculty at NITTR Chandigarh. He is also member of various professional institutions like Concrete Institution, American Concrete Association, to share your views among the audience.
Yeah, thank you very much. Satish did a nice presentation. Congratulations, Satish, on for that. And he explored you. He took you a journey to the whatever latest is happening. Now I'll try to draw back the students to basics. I would like to talk about concrete basics. So, what is the basics of concrete? And many of these things you must have learned in your classrooms also, but let's try to visualize it in a different way, and wherever you feel to interact, I would be open, and let's start with it. So what is concrete? Am I audible and my screen is being shared? Please respond.
Yes, sir. Yes, sir.
My screen is there?
Yes, sir.
Okay. So let's start with what is concrete. So basic thing is cement, water, fine aggregate, coarse aggregates. These four can also make concrete, but we are showing two things with plus. That is admixtures and mineral admixtures. Internationally, admixtures are compulsory constituents of concrete, but in India, it is optional. Once we'll be exploring, we'll be talking about what our things are. So redefining, somebody tried to redefine what if I take a piece of concrete, what it will all constitute. So it has a air to start with, 6%. And then in around 11% is Portland cement, 41% is gravel or crushed stone, 26% is sand, and 16% is water. So this is a set concrete. So what are the concrete materials? Looking at it, so it starts with cement, water, coarse and fine aggregates, admixtures if required. So this man is trying to carry all his materials, cement, water, sand, and finally what we get is a concrete. The aim of is to mix these material in measured amount to make concrete that is easy to transport, place, compact, and finish, which will set and harden and give a strong and durable product. Again, pictographically showing the same thing. So first major constituent is cement. So it's produced, how cement has been made, all of you must be knowing it. So let's try to skip it. A point to be noted here is it reacts chemically with water, and then it's a heat producing reaction. We call it hydration, which produce heat approximately 13 degrees centigrade for each 100 kg in per cubic meter. So we have a reduced volume leads to shrinkage. This is again a very important property, that volume of dried cement or concrete is less than the volume of wet concrete. So again, showing it pictographically, cement plus measured water, what we have is a cement paste. This paste acts like glue and holds and bonds the aggregates together. Types of cements, you all are aware. I'll just go through them. OPC, PPC, high early strength, low heat strength, sulfate resistant strength, shrinkage limited strength. But once you go to market, these two would be easily available, OPC and PPC. But if you want somebody to have a high early strength, you might have to struggle, because commercially the demands for these special cements is very limited. So we have to get back to the companies and request them to give us a specific requirement of cement, especially sulfate resistant cement. To some extent, PPC acts as sulfate resistant cement, but there are special grades also. Why we need to include cement to be part of concrete? So basically, cement is the binding material which holds everything together. So, and we all know its strength is higher at lower water cement ratio. Another important point of cement is it protects reinforcing steel in RCC. So it has a high pH value, which helps us to resist rusting of steels. Durability is again higher at lower cement ratios. So what is cement hydration? The physical change of cement paste from liquid to solid after reacting with water is called hydration. The chemical reaction starts as soon as the water is added, and it will continue as long as there is water and unreacted cement. It can go on for years. So initial reaction is from the aluminum phases. This is very fast and would give a very rapid gelling. Sulfate is added to prevent this gelling, allowing cement to be used. Silicate reactions are slower but produce the long-term strengths. The reaction is affected by external factors such as temperature. So how do we store cement? So we have to, all of you are aware, so we have to take care that it is not exposed to moisture or water. Aggregates. It can be a natural or crushed rock dispersed throughout the cement paste, largely for economical reasons, higher volume stability, and better durability than hydrated cement paste alone. Classification of aggregates. Aggregates are of basic two types, coarse and fine. So what is the dividing line between them? Is this sieve, 4.58. So anything which retains on this sieve and up to 80 mm is classified as coarse aggregate, and anything which retains in 75 micron to in the range of 75 micron to 4.75 mm is fine aggregate. So properties of aggregate. It has to be strong and hard. It has to be durable. It has to be chemically inactive. So this is again very important. We need to check our aggregates for this inactivity of chemicals. It has to be clean, no dirt or anything striking to it. Then, very most importantly, it has to be graded. It cannot be a one size only. So, because we need a packed high density product, so it aggregate has to be all size. This fine, this size, all graded aggregates, which gives us a stronger and a denser concrete. Then we have a rounded versus angular. Rounded are generally available from rivers. It's a natural made aggregates, and angulars are being made at crushers. So from bigger rounder, they are broken down to smaller angulars. Somewhere we talk about angular aggregates being better because of their interlocking properties, and sometimes even rounded aggregate can be considered better for lesser surface area and more workability. So we have to choose whatever locally available materials are there and then effectively use them to produce a stronger concrete. So even without using aggregate, we can produce what is called a mortar or aggregate, but then the cost would be higher for higher volumes. So this reduces the cost of concrete 1/4 to 1/8 of cement price, reduce thermal cracking, because 100 kg of OPC produces 13-degree temperature, which we talked about earlier. So it helps in reducing shrinkage. What is the effect of aggregate on concrete properties? So fresh concrete, so we can change workability, water demand, cohesion, pumpability. All properties are being affected by choice of aggregate, as well as choice of any of the ingredient. Actually, it could be water, fine aggregates. So all properties get affected. So we need to consider them. Coming down to next very important ingredient, water. So water is mixed with the cement powder to form a paste which holds the aggregate together like gun. It reacts with cement. It must be clean, fresh, and free from any dirt, unwanted chemicals, rubbish that may affect concrete. Many concrete plants now use recycled water also. So basically, what is the amount of water required for hydration to complete? So this is 0.25 to 0.17. But actually, if we use only this much amount of water, we'll not be able to attain what is called workability of concrete. So we use a little more amount of water, and for chemical process, this is the minimum water which is required. That is in the range of 0.25 to 0.27. So layman's rule is checking. If we can drink potable water, what we talk about is it is good for okay to be used in reinforced cement concrete. But with experience, what we have seen, nobody is able to provide drinking water for construction purpose. We have seen a lot of housing societies in around NCR, Delhi, Chandigarh, which are presently also suffering from chloride attacks, sulfate attacks, because they didn't honestly tested the water. And after 10 years, 15 years, there are a lot of deterioration coming up. And we are flooded with queries to take care of them now. And it becomes very difficult because chloride then becomes the integral part of the concrete. So we have to be very careful about use of water. Even if we use recycled water, but must test and honestly take care that water which we are using for making and even for curing should be of good quality. Then the optional thing we talk about is admixture. They can be in the form of liquid or powders or other forms. So let's come down to complete making process. My slides might sound you very basics, but let's go through them. And sometimes you visualize. And I have requested Devinder to give you all these study notes also in PDF form also. That becomes a lifelong lesson for you to carry along with as and when you want to refer. So first one is to measure amount of coarse and fine aggregates and mix together. Then we need to measure amount of cement which is to be added and mixed in. Then enough water is added to make the mix workable. All materials are then mixed together. So very basics. So what are the concrete properties which we look for? So workability, cohesiveness, strength, and durability. So we'll be looking after these one by one. Stages in concrete. We can define them: plastering stage, setting stage, hardening, and each stage it has different properties. So plastic stage, when the concrete is mixed, first mix, it is like bread dough. It is soft and can be worked or molded into different shapes. In this state, concrete is called plastic. Concrete is plastic during placing and compaction. The most important property of plastic concretes are workability and cohesiveness. And how to identify that, whether it is in plastic stage, is this diagram which is showing. A worker, if stands on a concrete and he sinks into, that means it is still in plastic stage. So it's a pictographic representation of to identify that my concrete is still in plastic stage. Then starting state, how to go about it. Rest remains same. If I am able to walk through with my footmarks on concrete, that means it is in the process of setting state. So a worker leaves footprints in setting concrete. Then hardened state, after concrete has set, it begins to gain strength and harden. Properties of hardened concretes are strength and durability. Hardened concrete will have no footprints on it if walked on. Workability. Workability means how easy it is to place, handle, compact, and finish a concrete mix. So first important thing is to place, then handle it, and then compact it properly and finish it. Concrete that is stiff or dry may be difficult to handle, place, compact, and finish, and if not constructed properly, will not be as strong or durable when finally hardened. A slump test can be used as a measure of workability of concrete. Largely, all of you must be knowing it. So we'll just again look at it. So what are the effects of workability? Workability is affected by amount of cement paste and aggregate grading. So this is how we can make it. So to make a more workable mix, add more cement paste. Use well graded aggregates. Use and a mixture. Never try to make a mixture more workable by just adding more water, because this lowers the strength and durability of concrete. Never just add water. As my colleague Satish also talked about it, this is a difference between homemade concretes and engineered concrete. So but it's the other way around. If we are aware of these things, homemade concretes can be as good as engineered concrete. So, cohesiveness. Cohesiveness is how well concrete holds together when in plastic stage. Cohesiveness is affected by the aggregate grading and water content. The mix that has too much water will not be cohesive and may separate and bleed. Strength and durability. Well-made concrete is a naturally strong and durable material. It is dense, reasonable, watertight, able to resist changes in temperature as well as wear and tear from weathering. Strength and durability are affected by the density of the concrete. Denser concrete is more watertight, less permeable. Concrete durability increases with strength. See, a people like me standing on a concrete and he's trying to define whether it is what is the strength, compressive strength. Okay? So basically, concrete is very strong in compression. So any amount of heavyweight person can stand on it and it can take strength. So it is able to resist that strength. So what are the factors which are affecting strength? The first factor is compaction, then curing, and then weathering. So this factor curing will be taking up. It's very, very important. And first part is compaction. The amount of air which is stored. The very first sketch we show that, okay, 5%, 6% air is normally present in concrete. But beyond that, even 1% increase reduces 5% of compressive strength. So we have to be very careful that compaction is done properly. So it is removing the air from concrete, proper vibrations, special type of devices which are called vibrators, needle vibrators, plate vibrators, poker vibrators. There is a huge range of vibrators and how it has to be used. Again, it's a science which needs to be taken care of. What are the factors affecting strength? So first is type of strength. As you must be aware now that we have various grades of strength, 33 grade, 43 grade, 53 grades, and even now beyond grades, we have PPCs which are having strengths up to 55 or 60 newtons. So the type of cement will define what are the what we can achieve as a strength. Then second important factor is water cement ratio. So as a layman, we can define what is it. So water divided by cement makes it water cement ratio. Too much water and not enough cement means concrete will be weaker and less durable. So just example wise, let's show it. See, if we are using 40 kg of cement and 20 liter of water, we have a strength of 35 MPa and water cement ratio of 0.5. Similar product, we have a 40 kg cement, but we increase the water quantity. Say instead of 2 buckets, now we use 3 buckets. We have a water cement ratio of 0.75. See, strength is going down to 20 megapascals. If we further increase water only, cement content remains same. Buckets of water instead of 2 going to 4, water cement ratio coming to 1, and strength further going down to 10 megapascal. So basically, the lower the ratio, the stronger the concrete. So this is also, you must have all have studied Abraham's law, which we'll be also talking. So this has to be kept in mind that the water, what we need to add water cement ratio, it should be as low as possible. So what we checked is for hydration, our requirement was only 0.25 to 0.27. But for workability, we start with say 0.5, then reduce it to 0.45 or 0.4 with the help of admixtures. So this is the curve. So this is the strengths on this line, and this is the water cement ratio. So say at 0.3, it is the maximum, and it drastically goes down. So we have to be sure of this. So further, effect of water cementation, durability also, permeability also, it affects all properties. So if we want to think concrete, sleep concrete, we have to always talking about water cement ratio. So this is Duff Abraham's law, who studied this, and assuming full compaction and at a given age and normal temperature, strength of concrete can be taken as inversely proportional to water cement ratio. So all of us as a civil engineer, so this has to be our mantra. For if we are talking concrete, let's talk about this. This has been covered by Satish. What are the ordinary grades, standard grades, high strength grades, and so what are the total operations? Storage, batching, mixing, transporting, depositing and placing, compacting, finishing, jointing, curing. So all these steps have been now represented by a chain. We call it a concrete chain. So let's see. Step 1 is identification of my ingredients. That is cement, aggregate, water, storage. I put the forming in place. I place the reinforcement. I mix them all, which is called batching and mixing. Then I do a test stage. What are the tests done at this stage is workability, slump test. Then transporting, then placing it, then compacting it, then taking care of joints and finishing, curing it nicely, removing foam work, and if there are some damages, then repair and patchwork, and then what we have is finished concrete. So basically, why we are calling it a chain? Because strength of the chain is its weakest link. So we cannot ignore any of the link, starting from cement, aggregate, water, storage, formwork. So that's why we are trying to represent this by a concrete chain. So all of us has to be very careful about that. My concrete, my total performance would be dependent upon my weakest link. So I have to take care of all these links, starting from raw materials to finished concrete. So, Mother, this sketch should be vividly remembered in our mind or pictograph in our rooms, workplaces. So that's how important it is. So concrete testing, in between we start about after producing, we go for slump test. How it has to be done, or compression tests. Largely it is, all of you must be aware, we'll just run through. So this is a test for workability of concrete. So workability measures how easy the concrete is to place, handle, and compact. So and then compression test gives us the compressive strength of the cured concrete. How sampling is done. So this is available in all standard books, and in your labs also. You must have been doing it, or not yet done. Then while doing it, you should be very careful of how samples are being collected. It's not that from one place we can pick it up. And how this lump cone test is being done. What is this equipment? What are the various other aids? How it's being handled. So compacting it twice, thrice, loading 25 times. 1/3 is filled once, second half, third half. So these are the steps. Second, 2/3, then overfloating it, then level off, carefully lift the cone. So then we need to take care of upside down. Then what is that? This depth has come A, B, C. So all these things have to be recorded, and then representing this. Similarly, compression test, we are supposed to fill cubes or cylinders. In India, we take care of cubes. In some countries, they are going for cylinder molds. So, so our cubes are largely of size 150 into 115 into 150 mm. Again, compacting in layers, taking care of their curing also properly, and testing cylinder is there. Minimum 3 cubes constitutes one test. And then what are the calculations? Size of the cube is this, area of specimen is this, characteristic compressive strength FCK at 7 days, expected maximum load area, then at 28 days load applied. So this is the way the strength is being calculated. So again, coming back to chain and talking about further points. Another point my friend Satish always talked about was engineered concrete. But what is a good way to ordering concrete? Nowadays, all metros, even state capitals and others, this engineered concrete or ready-mix concrete is available. But what is a nice way to order for an engineer? So that needs to be looked into. And what quantity, what grade of concrete we need. So that can be. So let's look at it, how we go about it. First was normal class concrete, which we have talked about. Then we'll be talking about special class if we required. Then additional data for ordering. So this is the one most important thing is slump in mm that needs to be measured and ordered. Okay, that this is the slump I need at my site. And even you can define times. One is at arrival, one is at the time of placing. That could be after 30 minutes, 40 minutes. So slump retention has to be taken care. Then maximum aggregate size you need to order. Then whether you want to place it by pump, shovel, or dump. What is the time interval between truck loads? Because all concrete cannot come in one go. So a certain quantity which my transit mixer can carry will come. So all these things, whether we want admixture to be present, all these things need to be taken care while you are ordering. So for this information, and then in situ concrete is how we place at things. This is proportionately how we proportion them by volume. Again, we have Satish has talked about 1 to 4 thing. Earlier we were talking about volume. Now we are going for wave batching. Higher the cement, the higher is the strength. Water content, it is the other round. The higher the water content, the strength is coming down. In this case, it was upward. In this case, it is downward. So again and again repeating things. So water cement ratio, this is again critical. Then aggregates, mixing, these are desi mixer, but nowadays all technologies have gone up. But still, in India, 30-40% sites, even this is being used. Then this is truck mixing, the TM which is coming, it's continuously mixing. The materials are normally added to the trucks at batching plants and mixed for required time and speed at the plant. The truck's drum continues to rotate to agitate the concrete as it is delivered to site. So planning and site preparation, what are the requirements prior to ordering concrete or manufacturing concrete? So all these things, steps we need to take care of. Safety also, planning and site preparation. Then steps in site preparation. So we need to measure the quantities. We just cannot order a concrete or start producing it, but site we can manage to some extent. But for ordering it, we need to be very precise and we need to take care of 1 or 2% of wastage also. Then finishing levels. So formwork has to come that for example, this A, C, B, C, it cannot finish at C. So we need to take care of the driveway that first this has to come, then this has to come, then this has to come, then this has to become. So prior to that is soil, we need to take care of subgrade preparation. Then formwork erection has to come. Then whatever services or pipes has to be carried, it has to be taken care, they are put in place. Some underlaid services, electrical conduits or other things, fan boxes, other things, they need to be placed. Then reinforcement location is at right place. Then assess placement and joints, because our concrete cannot be continuous 24 hours. If we need to stop, we need to have a planned joints. So transporting and placing concrete, so delay, segregation, waste. The method used to transport concrete depends on which one is the lowest cost and easiest for the job. But nowadays, with a lot of pumps coming into place, so that becomes the easiest thing. Otherwise, head carrying, people had to take care of it on farm work. They have to do it. But now we are able to, then placing comes. Delay is there. Segregation. So what is segregation? It is when coarse and fine aggregates segregate and cement paste becomes separated. Segregation may happen when the concrete is mixed, transported, placed or compacted. Segregation makes the concrete weaker, less durable, will leave a poor surface finish. So we have to avoid it. Again, water cement ratio will come into play. If that's the optimum, so we need to check it is not too wet, not too dry. Make sure the concrete is properly mixed. It is important that the concrete is mixed at the correct speed in a transit mixture or at least 2 minutes immediately prior to discharge. The concrete should be placed as soon as possible. When transporting the mix, load carefully. If placing concrete straight from the truck, pour vertically and never let the concrete fall more than 1.5 meters. So this is the optimum. So we need to check it is not too wet, not too dry. Make sure the concrete is properly mixed. It is important that the concrete is mixed at the correct speed in a transit mixture or at least 2 minutes immediately prior to discharge. The concrete should be placed as soon as possible. When transporting the mix, load carefully. If placing concrete straight from the truck, pour vertically and never let the concrete fall more than 1.5 meters. So this things needs to be important, especially for column castings, because sometimes we have a formwork as high as 3 meters. So this has to be taken care of. Pipe or dummy needs to be trimming needs to be taken down, so that the fall, once it falls from more than 1.5 meter, coarse aggregates, fine aggregates, because of their different densities, try to move at a different speed and then segregate. Always pour like this. There are chutes for this, so that we don't need it from top or dump it from wheelbarrows. Another caution is there: never spread concrete with a vibrator. But this is bound to happen if not vibration is not done carefully. So what is the ideal way of compacting a concrete is taking this vibrator nozzle straight down and straight up at a particular locations, then not in a trying to push the concrete by the vibrator. This is the way, this is the straight way what we are talking about. If you shake and vibrate the concrete, the air is pushed out. So these are the air bubbles which are going out. Then the question is when to compact. Compaction must be done as concrete is placed while it is still plastic. Never let concrete dry out and stiffen, because it will be too hard to compact. So these are the words impact. So properly compacted concrete is more dense, strong, durable. Offshore finishes will also be better. For concrete of average workability, that is lump of 80 mm with a porker size of nozzle that is between 25 mm to 75 mm, concrete should usually be vibrated for between 15 to 30 seconds. It is worse to under vibrate than to over vibrate concrete. So if you are not sure, vibrate it once more. That's much better than doing it under vibrate. So this is 25 to 75 is a nozzle size. And this for slab placement, 75 would be okay. For closed, very confined reinforcement, we need to have a needle size for columns, beam, which could be of size 25 mm or 40 mm or 50 mm. So this is external vibration, which is done by screeding, mechanical